It slaps your elbow against your ribs.
Good enough. I don't have anything else to add to this. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 313, Capacitor Plague, Wireless Power, and Tiny Everything. This week in Hackaday news, both Jenny and I were at Hackaday Europe last weekend and had a great time.
Indeed, Berlin was as anarchic and grubby and amazing as ever.
Poor but sexy.
Yes, I'd say that, yes.
That's the old stereotype joke, but Berlin is fantastic.
The discovery for me was Exane Hackerspace, which is not too far from the Hackaday Europe venue. I've been to many hackerspaces in Europe in my time, and normally they are a little, probably slightly dilapidated industrial unit, and they're normally down some alleyway or little road. Then they're not on the path more trodden. But Exane, you're walking along a prosperous street, and suddenly you turn into a shop, and there's an amazing hackerspace. And it really was. It was a lovely place to spend the Sunday afternoon. If we've got any Exane members there, I can only extend my thanks. It was an amazing place to spend an afternoon.
I think Dave Darko was one of the founders of Exine, but a lot of people in the Hackaday community are there. I know Tina Belmont's there. Since she moved to Berlin, she's kind of a fixture there. Tons of people. It's not even that huge a space, but I've met tons of people from Exine at one event or another.
I have major space envy, and the various spaces I'm members of are actually pretty damn good spaces by my estimation, but that one is a very nice one.
And Hackaday Europe went off without a hitch. The badge plan this year was, can't believe that all of the 4 SAOs got delivered on time. But there were all sorts of logistics issues.
Do we tell them about Thursday and Friday?
We're just about to. There were all sorts of logistical issues, including manufacturers came up short of some parts. They soldered some parts on in 180-degree orientation, most particularly annoyingly, a flat flex connector that must have had like 18 or 20 pins on it. I'm sure you actually can count them all. And last up, of course, half of the SAOs got impounded by customs. Didn't even get them back to Berlin until 6 p.m. the Friday night. And that's only because Bogdan drove over to Leipzig and fetched them in a car. You were a big part of the badge saving team.
Yeah, I have form when it comes to badge sweatshops. I've been in more than one myself. To me, the biggest hero from the technical point benchwork event was actually Voya Antonich, because one of the SAOs had a pick on board. It was an older pick too. It needed an older pick programmer, which of course he had one with him. But for some reason, known only to its designer, it's the programming footprint was surface mount pin header, the ones where the pins are splayed out alternate sides. And of course, we didn't have any of these pins to hand. And Voya fabricated a programming jig for it from scratch and was able to program them all, which is hero work.
Yeah, that was the Vectrex one.
It's amazing SAO. As I say, we were saved by Voya having the programmer.
Yeah, Brett Wallach, a.k.a. Technobly, who made this, cut a bunch of corners, including using this like archaic pick, quote, because I have a whole bunch of them on my junk bench. And then
impressive.
He also only soldered a couple of the surface mount programming headers on there. And for whatever reason, our folks didn't attach them either. I guess it wasn't too bad. Once Voya made that programming jig, of course, it's probably just as good as having the header on there. So no harm, no foul. But that one also needed the keyboard soldered onto it. And you did a whole bunch of those.
I did a lot of the keyboards. Beautifully done. I believe they did it in the design lab. A piece of stiff wire with little flexible wire wound around it to make the coily wire look. It was actually looked rather cool.
It looks great. Yeah, that was worth it.
This brings up something which I'm not sure whether one of my colleagues has already written. If not, perhaps they should, on choice of programming headers for small microcontroller boards. My favourite is when you take a row of holes that you might use for a normal through-hole pin header and you offset them in a very slight zigzag. So your programmer becomes effectively a normal row of pin headers. But because the holes are offset, you can push them in, but they're held in by friction. and then you can program them. Alternatively, I've seen the ones where it comes to something looking a little like an edge connector, and you have something like a clothes pin with a set of pins on the end, which you clamp onto the edge of the board.
The capacitive touch wheel SAOs that Toddbot made, those have 1/10 of an inch surface mount pads on them, 4 of them. It's really simple. And he made a lovely little pogo pin, kind of clothespin like grabber jaw jig for that. And because they came in at 6 p.m. that night, I was up till midnight flashing all 300 of them. It was actually really easy because, it was a good flashing jig, and it probably only took 5 or 10 seconds a piece. And the design lab people were there to like unbag them and rebag them too, which made things go
Yeah.
a lot faster.
At one moment, it was all hands to the pump. We had supply frame, and I believe we had some of the crowd supply folks helping as well. We must thank them.
Yeah, that was insane teamwork from basically everybody who was within a 1 kilometer radius. That was really, really super. And we had some other volunteers too. So yeah, just thanks to everyone who made that work. A lot of hard work, a lot of love put into these, but the result just was so, so, so cool.
I don't think anybody had been to an event where they open the bag and instead of a badge, sheer number of different printed circuit boards in there, because it wasn't just that there were several SAOs and the carrier board. One of the SAOs has several pieces, but there were a couple of promotional PCB rulers in there as well, just to up the PCB count.
What I liked was that in true Hackaday style, some of the software / firmware was actually being worked on Saturday. During the conference, some of it was still being worked on. And, anywhere else that would be a problem, but with our crowd, it's like, hey, can you figure out how to flash this microcontroller? And the answer is yes. Everyone in the room can, or, at least half of them.
Yeah.
And they can help the other half. So it was actually no problem. And, I think a bunch of people have had more time to play around with the badge and stuff in the intervening few days, and pull requests have been pouring in. I am going to get some free time to review them, hopefully this weekend. So if you've submitted any, I'll get around to it this weekend and check that out.
Virtually every event I go to, I'm running around looking for things for Hackaday. At least that's the impression I want you to give. In fact, I'm sitting in the bar watching everything on video, but I'm basically doing stuff, and I rarely have time to really play with the badge at the event. So if I get a badge at one of the big summer hacker camps or something, it'll usually be a few weeks afterwards that I'm sitting down in my hackerspace playing with it. And it's a shame, because I wish that I could do more of this hacking on the event. But then again, I'm doing lots of other fun things, and I hope you guys appreciate them.
Well, I had this absolutely marvelous 5-hour-long train ride home on Monday, and I spent about an hour and a half of it scheduling Hackaday posts, and then the rest of it hacking on some of the different firmwares for the different SAOs and stuff. And that
sounds like a very good use of it.
Just so nice to have a little time to sit back and do that. Even if it wasn't during the event itself, when everyone else was messing around with it, I got to see what everyone else had done during the con. Put that on there and start to play with it. That was a nice time. Being on a train sometimes is a little bit like an enforced timeout, and an enforced timeout with a bag full of hacky goodies is absolutely lovely.
I like rail travel for the hell of it. And for me, sitting in a high-speed train across Europe for 4 or 5 hours is great office time, because they're usually very comfortable places to work. The internet is a bit variable, I will grant you that, but they nearly always have power. They always have basically somewhere to get decent food, and they're very quiet and comfortable. And so I do some of my best work on trains.
Well, thank you everybody who was there for making Hackaday Europe the success it was. Again, these things really boil down to the people giving the presentations, the people sitting there listening to the presentations and interacting with our speakers, and hacking on the badge. The badge hacks were fun. The lightning talks on Sunday were awesome. The main talks, of course, on Saturday were all great. And yeah, I think just everyone had a good time, and thank you all for bringing your good energy and your A game to it.
Yes, thank you so much. That was a brilliant weekend. I hope everybody has as good a time as we did.
And without further ado, let's do a What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This is a Guess the Sound week. So we're going to play a brand new sound for Jenny to guess. And after she gives it her best guess, you all will have a chance.
Well, that one is very, very easy.
That's what I thought.
But it's very, very easy given my and I grew up around a and I'd recognize the sound of anywhere.
Very good. I'm going to have to cut all that out about because it's way too leading, I'm afraid. If you know what the sound is, head on over to hackaday.com/podcast. Scroll on down to what's that sound, click on the link, fill in the form with your best guess and your handle, and you'll be in the running for a Hackaday podcast t-shirt next week. Well, our first hack this week is, well, it's not so much a hack. It's an awesome video from Asianometry about the capacitor plague of the early 2000s. Basically, a lot of consumer electronics gear started failing, and all of them with the same problems. That is, busted, blown open, leaky electrolytic capacitors, often in the power supplies. And the question of what happened to make this kind of quite the systemic problem that it is, and it hit, things I've seen bad electrolytic capacitors of that era in things like computer power supplies. I've seen them in large screen LCDs. I've seen them in, actually, that's it for me. The question the video tries to answer is what went wrong and how. And the early 2000s are kind of a time when a lot of component production shifted from Japan to China and got made even cheaper over there, basically. And one of the stories about what happened here is that some people at a Chinese manufacturer stole the secret electrolyte formula from Japanese company Rubicon, and this actually showed up in print in a magazine, and a lot of people have thought that that might have been the problem. What's neat about this Asianometry story is that he kind of dives deep into this and says, look, it probably can't be the case because you see capacitors failing across the board from a whole bunch of different brands during this period. And of course, some of them are fake, some of them are counterfeits, some of them are made in China, but again, some of them are made in Japan originals too. And so it's hard to say. Certainly one failure mode, and this is kind of the Rubicon story, is that the electrolyte formula is missing a depolarizer, and it over time gets too alkaline. So this was something this is kind of an acid that they added in to keep it from getting oxidized, keep it from getting too alkaline over time. If it gets too basic, it then can dissolve the dielectric, expose itself to the aluminum. Aluminum plus hydroxide makes gas, and then it'll bulge up and explode. The point that Asianometry makes is that it can't be the only story because this is happening across too many different capacitor manufacturers. There's a really neat tangent here where he goes to talking about the different chemical brews that are in the electrolytes and their importance for the capacitor. And that alone is worth the price of admission, in my opinion, here.
Yeah, very much so.
The Xbox had failing supercaps, and they were made by an American company. Dell had a computer, the Optiplex G270, that had capacitors made by Nichicon, which is A1 Japanese capacitor manufacturer. And all of these kind of point to it having to be a different story.
There's an interesting thing about that era. I was just thinking it as you sort of described it. That was a transitional time. Switch mode power supplies have actually been around for a very long time, but it was through the late 90s into the mid 2000s that the traditional iron core mains transformer started to disappear. There was that period when probably the economics of a switch mode power supply became much more viable for mass market stuff compared to an iron transformer. And it's quite likely that, aside from the dodgy capacitor story, which, as the piece points out, may or may not have quite as many truths with the stolen Rubicon formula as received opinion would have it, it's quite possible that it was just general cheaping out as designers who hadn't really brought switch mode power supplies down into this level of consumer device learned by failures. I wonder how much of it was that.
moving away from transformer base and towards solid state power supplies here, at the same time, computers were getting hotter and faster. And it may just be that they were boiling over. And that certainly is what it looks like. I mean, if you look at these caps, right, they've popped the vent. It looks like, they let their gas out and then they got dry and then they failed. So it's consistent with them being overheated. And then what may have caused the end of the capacitor plague is the multi-core processors that kind of came online in 2010-ish and ran a lot cooler and more efficiently.
That's true.
Yeah, so I really like the story that Asianometry tells, is that it's really just they got too hot. They were put in a place that got too hot and they failed.
Yes, the device I always think of when I think of this is I had a very early PVR, hard disk video recorder. It went through several sort of faults where a single capacitor would go, and I'd take it apart and replace it before I just replaced the whole lot. I suppose it did get quite hot because, yes, it was a 1U box and it was in a stack under my telly. So, yes, the heat theory probably works there too.
And one of the things I learned is that the dielectric mix has antifreeze in it, well, I guess diethylene glycol, to keep it from boiling over. So it raises the boiling point as well. So not only are there chemicals to keep it from changing, from getting too basic over time, but also to keep it from boiling over. Who knows what else? Asianometry points out that the secret formula in the dielectric is well guarded, and it's, kind of the secret sauce in making electrolytic capacitors from firm to firm, which is neat because, that tells you why the Rubicon story got told. And there probably was tons of industrial espionage, and one firm was looking at every other firm's electrolyte formula. I'm certain. God, can you imagine the intrigue of electrolyte formula theft? But anyway, it's a really neat take on the whole thing. And what if the whole plague wasn't actually a capacitor plague at all? It was just bad thermal design.
Okay, my next one is it's actually quite a quick, almost dare I say it, simple thing, but the results are beautiful. Inexpensive thermal cameras. Thermal cameras used to be very expensive, and they've come down progressively in price. I reviewed a really, really cheap 16 by 16 one using, I think it was a sensor for gas flames a while back. But if you want to go into decent level thermal cameras, you're not spending an enormous amount. And there are little modules that will plug onto the top of a mobile phone, for instance. And somebody's taken one of these and they have turned it into a thermal microscope. Just as you do with an optical microscope, you shove a bunch of lenses in front and you make sure it focuses up. But in this case, the lenses are not off-the-shelf glass lenses. They're germanium lenses, which I'm not sure where you buy a germanium lens, but I suspect that it's quite expensive. And they've stacked up 3 of those in a 3D printed cover over the front of an affordable thermal camera. And they made a thermal microscope, and you can look at individual features of components. So, for instance, when you look at with a normal thermal camera at a printed circuit board, you just see a sort of blob of heat over a chip or something like that. Well, they're focusing in. One of the pictures, for instance, is a power transistor, and you can see the individual places where the heat is. Or I think one of them is a wire-wound resistor. You can see all the coils of the resistor. And I don't know whether my interest was caught for this. The hack itself is, on the face of it, quite simple because, yes, they have put a lens in front of a camera. But in terms of the lens that they put in front of the camera, the availability of germanium lenses for this purpose is definitely something I hadn't come across. And the resolution that you can gain that way with a thermal camera, I had never seen before. I find it beautiful as artwork. I find it fascinating as an engineer to be able to delve into the thermal properties of components at a much higher resolution. And I think you will too.
As if I don't want a thermal camera bad enough. The idea of actually being able to focus down on what you want to look at makes it even more appealing. These lenses are super common these days because they're the same ones used in infrared lasers. So if you have a CO2 laser cutter, these are CO2 laser cutter lenses. And depending on what focal distance you need, you can get them dirt cheap, like like $10 for a lens.
Gosh.
He's talking germanium. The germanium lenses are a little bit expensive, but the zinc selenide lenses are
Okay.
dirt cheap. And that's, for instance, what my laser cutter has in it. And they come in focal distances from kind of 1 inch, inch and a half, 2 inches. The zinc ones may be a little bit toxic. I think you're not supposed to touch them with your bare skin very often.
Anything with selenium in it you want to avoid?
Don't lick it.
No.
But other than that, I don't think it's such a big problem. But yeah, it's a funny offshoot of, CO2 laser cutters being commonplace these days, that you can get focusing IR lenses. And so boom, a little 3D printed jig, put it over your IR camera and you're off to the races.
Obviously, these infrared cameras of this type are very different from the infrared cameras like the little Raspberry Pi camera, the one where you take off the IR filter and suddenly you can see in the dark with your little microcontroller camera.
Yeah.
But it would be interesting to stick some of these lenses on that type of infrared camera, which is, I believe, is it near infrared and far infrared? So just below what you can see. It'd be interesting to put a lens like this on those type of infrared cameras and see if it could pick up anything of interest from obviously a much cheaper camera.
Right.
It's just as an experiment. There will be optical specialists telling me in no uncertain terms why this cannot happen, but it's worth a try.
I think the real trick that the FLIR and other units like that bring to the table is that they can tell by the spectrum emitted what the temperature of the object is.
Yes.
And that bit, I think, is too hard to do with the limited amount of light you get and the limited resolution you get on a normal camera sensor. Otherwise, these things wouldn't be so damn expensive.
I was thinking more from the point of view of taking pretty pictures in that context, it has to be said. But yes.
Well, my next hack comes from Hyperspace Pirate, transmitting wireless power over longer distances. I love the beginning of this video because he starts off with, if you hate extension cables and also hate energy efficiency, I've got good news for you. Wireless power transfer can solve both of these problems at once. People have always wanted to beam power from one place to another. And, this was like Tesla's big dream. As Mr. Pirate points out, there are two main ways to do this. One is capacitive coupling, transmitting the power in the form of electric fields, and the other is inductive coupling, where it's magnetic fields. Tesla's idea was to transmit it using capacitive coupling, so it was all electric field, and this involved extraordinarily high voltages and high frequencies to make up for kind of the low coupling capacitance between any 2 points that are physically separated from each other by a bunch. As Hyperspace Pirate points out in this video, the kind of Achilles heel in the Tesla strategy is that they have to have a common ground to define the electrical potential between the two of them. And as you get further apart, having a common ground gets harder and harder. And
Yes.
Maybe you even need a wire. So an easier solution then is magnetic coupling. And basically you just make a coil on one side and a coil on the other, and you transmit magnetic fields between them. And he says it's like a transformer, but without that metal piece in the middle. And there you go already. There's your problem right there. That metal piece in the middle makes them tremendously efficient by kind of confining all of the magnetic fields and making sure it runs through both coils. Whereas if you're in open space, the magnetic fields spread out and you get tremendous loss because they're not focused, right? But that doesn't stop him from doing the experiments here. And he goes from smaller coils to bigger coils to even bigger coils, and from lower voltage to higher voltage and even higher voltage. He has one coil that's about 1 meter wide and then finally ends up with a loop that is 15 feet, so 5 meters approximately in diameter.
Gosh.
And just a lot of wire wrapped around these crazy 2x4 formers, right? And this thing is drawing about 300 watts and is able to transmit almost 2 watts at a distance of 10 feet. So again, you don't like efficiency? This is the way to do it. But the problem is it drops off as the distance squared. And so it gets even worse and worse. And by 18 feet, he's got half a watt. And at 40 feet, there's almost nothing measurable. And it can light an LED at 80 feet. So that's kind of what you're looking at here is 300 watts in and a barely visible LED at 100 feet. not a practical hack, especially since the voltages to make this work were so high that they actually were arcing across the wires that are wrapped up together in this coil. So, you want to make this giant coil with a whole bunch of turns, but you can't pack the turns too close to each other because there's, a few hundred, maybe 1,000 volts across them, and they arc on each other. And indeed, the very end of this project was that it was arcing unbeknownst to him and caught a little bit of the wood on fire, and he decided that the shenanigans were over and that this thing had, he'd learned everything he could out of it. But along the way, if you want to play around with this sort of thing, there are some really neat choices made here, and he displays all the different steps of working through it. So it's just a really great electronics tour as well. But if you wonder why all of the wireless power transfer things you see, like the Qi coils and stuff, are flat against each other, and why they're perfectly aligned with each other, and why Apple's MagSafe thing goes to such extents to make sure the coils are lined up with each other and almost touching, well, this is why. If you ask me, I think you should just run a wire.
Yes. I suspect he may have invented inductive room heating. But there are two things that occur to me from this. One is something that worked, and the other thing is something that didn't work. Now, the thing that didn't work was, you mentioned Nikola Tesla and his global power transmission system with the big tower and everything. What interests me about that is the way that he was, as often people like him were in those days, a bit of a salesman, and he announced to the world that he was going to transmit limitless power around the world. And it didn't work, but you will find almost a conspiracy theory level of belief that it should work out there if you look on the internet, that somehow he unlocked the secret of power transmission when in fact it didn't work. And you'll almost find people claiming that he was shut down by Big Copper because they wouldn't sell. There's some dark holes in the internet if you read up on that. But at the other end of the science of this, it was a very popular thing in the 1920s, and we have all gained something very useful out of it here in 2025. Magnetic or electrostatic transmission didn't work, but there were people who looked at electromagnetic field transmission, particularly in Japan. Professor Yagi and his student Mr. Uda, which probably means that Uda did the work and Yagi took the credit. We get the Yagi antenna. Now, if you probably recognize a Yagi antenna if you don't know what it is. It's a long boom with bits of wire sticking out either side. It looks like a sort of a comb or a ladder almost, and you point it at the a transmitter, and it's very directional. If you live somewhere that still has terrestrial TV, you'll probably have a UHF or VHF Yagi on your roof pointing at the transmitter. And the whole point of the Yagi was they were going to transmit power by having a dipole antenna and having a row of tuned radiators, resonant elements in a row between the antenna transmitting and the antenna receiving. And the idea is that these would stretch off across the countryside and power would be transmitted by radio. In fact, it didn't evidently work because we still use big copper wires to transmit electrical power. But what they did find is that they'd made a very easy to make and highly directional antenna, which we still use. So it's a good example of, while not all research does what it's intended to do, it can sometimes bring up unexpected good results that are very useful everywhere else.
Well, that's lovely. I didn't realize the Yagi came out of a failed power transfer experiment.
That was the idea.
Anyway, if you want to dig into wireless power, or just want to know why you don't want to dig into wireless power, this is a great video. He's done a similar one on inductive heating, which is, of course, basically the same thing, except the thing you heat up is the receiver, and that works a lot better. So check that video out too.
A bunch of the people at Hackaday Europe at the weekend has just come up from the Embedded World conference in Nuremberg. And one of the exhibitors there was a company called Decimo, who are, I believe, some kind of electronic consultancy. And they have a giveaway on their stand, which is a decade resistance box. And it's made in a similar way to an electronic badge with PCBs, and the PCBs form a wafer switch, and you've got a load of surface mount resistors, and you can dial in a resistance. I kind of like it because I'm a fan of badge life and electronic badges, and it's a different take on the kind of thing the badge people are doing, in that it's completely passive, very useful. It's not something you could replicate more than once, because how many people need a resistance box? But as a piece of PCB art, I really liked it. But that is not the reason that I'm talking about it here, because it used little PCB spring contacts. If you've ever whipped the back off most mobile phones, you will find that on the back cover is the antenna, and the antenna is usually some kind of flexible foil PCB with a fractal design. And the little things that make contact with it are like a little springy little box with a little springy bit sticking out on the PCB. And as you press it up, it makes contact against that securely. And this uses those. They're actually quite difficult to find. I know this because we spent a while in my hackerspace yesterday. We were trying to identify these things because they also appeared on one of the shitty add-ons that was part of the badge pack. The shitty add-on was one of those bouncy floppy man things that American car lots have. Elliot, help me out. What's that called?
Deborah's Bendy Man SAO.
Okay, the Bendy Man SAO had these little spring contacts because it had a circular joint between PCBs that could move. But finding these things was difficult, and it turns out if you start looking for antenna contacts and spring contacts, you start finding them in your normal PCBA website. I would like to see more use of them. I think that they are a neat technique for making PCB art that is different. I hope that other people pick up on them and do fun things with them. I like to see the art of the badge move on and not just be yet more blinkies. And I'm quite excited to find this particular component. Obviously, it's a component I knew about, but I'm quite excited to see it used in a badge-like situation because I think it has more potential and more things can be done with it.
Yeah, Deborah Geek Mom Ansel is the one who did the bendy PCB, and she has done a bunch of circuits where PCBs have to go around corners or turn relative to each other or whatever. She's absolutely the master of finding the right funny connector to go between PCBs when they're doing something wrong. I love this one because, like you say, she found these spring connectors, and I think they probably were from, meant to be battery connectors or interboard connectors.
Okay.
And they're just fantastic looking. You could think of a million different ways you'd want to use them, of course. She uses them as slip rings. Absolutely a fantastic technique. I love that Deborah submitted this one for the least manufacturable SAO prize, and then the design lab people were like, oh yeah, we'll make it anyway. We left assembly up to the people at the show, and this one was also assemble it yourself. And I think that's because there's a lot of parts, a lot of moving parts to get it to work. Did she say what this was? I bet she has if you look at her bomb, I bet you have.
I should have thought of that. You know how it is, you're sitting in a hackerspace and the next minute you're combing through component lists trying to find the thing.
That's right.
The obvious thing would have been to have found the design and find what she actually used, but it's easy to be wise after the event.
Deborah says amphenol 1014319-009 RLF, and actually has a link to buy them.
And Jenny says the cheap Chinese equivalent.
Exactly. Same thing, but in cheap. Well, my next hack is a virtuoso performance from Mike Roller, world's smallest blinky, now even smaller. And you got to look at the featured image on this one. It is of a pen held up next to this PCB that he made. And, it's a roller ball pen. The ball is probably half the size of the PCB. And what's wild about this is Mike is doing PCB fab at home and wanted to test out his manufacturing process and see how small he could get it. And so he made this, which is by far the smallest PCB I've ever seen. It's 3.2 by 1.6 millimeters large. And I think he's actually shaved it down to like 2 and a bit by 1.5 by shrinking some of the components. But the one he has assembled and actually blinking here has a microcontroller on it. It has a capacitor, which he uses as the power supply. You charge it up and it runs for a little while. It has an 0201 LED and a current limiting resistor. And of course, a power supply decoupling cap as well. Unbelievable. This is all fit on this absolutely tiny little PCB that he made, which also has, and I don't think you can even see it in these pictures, absolutely tiny little homemade vias in it. I want to see this PCB manufacturing technique, and I've actually asked Mike to do a write-up of that for us because I think that's actually the most amazing part of this. But still, this project is really, really cool, and it uses a tiny, tiny little microcontroller. It's an AT-Tiny 20 in WLCSP. And if you were reading Hackaday last week, we wrote up an article about an even smaller microcontroller, which we'll talk about later. So it's possible to make this even smaller, which would be absolutely terrifying. But what I really want to see out of this is how Mike is managing to make these PCBs that are so small I couldn't even handle them without dropping them or
Indeed.
losing them. You know, I would need a microscope to see the damn thing, much less cut it out from a blank. Apparently he's got a laser etching procedure, but they look phenomenal.
I want to see this become the world's most evil soldering challenge kit. The funny thing is, if you did that, I'm not entirely certain I would be able to hand solder one of these. But
you absolutely wouldn't.
I'm certain that among Hackaday's readers, there would be amazingly somebody who could.
Yeah, this is clearly put paste on it and reflow it type material.
Reflowed.
There's no way to do this with your hands. I mean, A, the ball grid array, but B, 0201 parts. I mean, he has a hot air reflow pen, which looks like an even lower flow version of what we're all used to, which is probably necessary when you get down to this
You would
size.
have to hot air reflow it. I was kind of joking about a soldering kit, but Hackaday readers never cease to amaze me with their skills. So if somebody could assemble one of these by hand, I would make a fair bet they'd be a Hackaday reader.
That's right. Mike, if you're out there listening, you absolutely have to write up your PCB fab methods. I'll keep hassling you about it until you do, because this is so amazing looking.
Right, my final one comes from Chris Doble, and it's a GPS receiver from scratch. Now, what he's done is he's taken an RTL SDR, which of course most people have for like €10 or whatever, $10, and he's written a GPS receiver for it. Now, this is not the GPS receiver that you'll have on your phone or your Garmin or whatever. It's the coarse version of GPS, so it's a few hundred meters, but it's still a fascinating project. He's published the software, but probably the most value for me came in there's a load of videos where he really goes into depth in how a GPS works. Probably not many of you are going to use this as a GPS, though it's an interesting thing to fire up, and if you have a RTL SDR, you can. But in terms of learning how GPS works, how the maths is done, how the timing is done, and how the signal acquisition is done, it's fascinating. And I really recommend anybody with an interest in this have a read. Of course, when we want GPS, we all just buy a GPS module. They're a few quid, are they? A few dollars. You talk to them with a microcontroller, you get back the position. But knowing something about how it works is never a bad thing.
I haven't gotten a chance to watch the videos yet, but the resources he has, even just on his GitHub page, are phenomenal. Man, I don't know when I'm going to get the time to go through this, but now I really want to. And of course, if you need to spoof a GPS signal. My first quick hack this week comes from Look Mum No Computer, reviving a Maplin 4600 DIY synthesizer from the 1970s. This was a magazine build-it-yourself synthesizer, and it has a bunch of weird synthesizer architecture choices. If you're into old synths, you should definitely look at this video. It's got the strangest mixer architecture I've ever seen, and it's got this lovely patch pin matrix. Next up, Jacob of Painted for Combat, and that's like little tabletop combat model figures, Make fancy resin printer 3D models FDM friendly. And this is a cool idea. A lot of people make their tabletop models using SLA, and SLA models often have built-in supports. The question is, what do you need to do to these supports to make them work well with FDM printers? And he demonstrates here that you can kind of isolate them, thicken them up a little bit, and they work just fine. Next up, Natalie Gelbert comes with an art project, Chemistry Meets Mechatronics, in this engaging art piece. It's filled up with whatever that litmus indicator is you get out of red cabbage. There are a bunch of electrodes in it that turn the solution on one pole red and on the other green. It's really marvelous art, but it's also really cool chemistry, and I'm still not sure I understand it fully. Makes me want to try the experiment. Kevin, Current Mirror's Tame Common Mode Noise, is a nice long video, but he demonstrates a bunch of cool uses of current mirrors. So if you're into analog design circuitry, you should check that video out. And along those lines, if you're into microcontroller stuff, Larry Banks, Speeding Up Your Projects with Direct Memory Access, is a fantastic deep dive into DMA and why you would like to use it for things like writing to screens or high frequency sampling from ADCs or something. If you're still scared of DMA, he shows you how you can use it in the context of an Arduino project. Although it'll probably work with any of them, you will probably have to get into the data sheet because DMA controllers get you a little bit closer to the hardware peripherals.
First on my list today is Pebble. Now, do you remember Pebble? They were the smartwatch that was first to the table back in about 2013. Quite a simple device with a microcontroller and a simple screen. They, I believe, got taken up by Fitbit and eventually sort of died sometime in the later half of the 2010s. Well, they're back. I think Google ended up owning the code and open sourced it, and somebody is releasing a pair of Pebble smartwatches. If you want to relive 2013, that's great, but I suggest you do it quickly because for some reason known only to them, one of them is called the Core 2 Duo, which means that I think they've picked a marketing strategy of get sued by Intel. So next up is Fesh with an article on turning down the noise on switch mode power supplies. If you have ever worked with switch mode power supplies, you know that they are incredibly noisy, or can be if you're not careful. And particularly if you're working with any sort of audio or low noise circuitry, it becomes very important. So that's a really interesting piece if that's what you need to do. Following that up, Caleb CCF produced an entire 6502 microcomputer system with processor, ROM, RAM and serial port. And what makes this one interesting is that he did it entirely in shell script, BusyBox Ash shell script. And from the shell, you can run an entire 6502. It'll run code, it'll run BASIC, it'll run WASMON, and anything else you throw at it. I like it because everybody knows that shell script can do everything, but sometimes we forget, and here it is doing some pretty impressive stuff. And finally, snappiness. This one tickled my dodgy old camera sensibilities. They found a Kodak picture maker kiosk. Now, if you were around sort of 20 years or so ago, every shop had one of these. You would take your CF card or whatever it was from your digital camera at the time, stick it in the machine and print out photos because everybody wanted traditional photo prints. They've kind of pretty much disappeared, though I did actually see one a week or two ago when I was last in London. I was quite surprised to see one. And this one, he's got a second-hand one. It doesn't work. But it was interesting, when he opened it up, he found a Sun workstation inside, not the expected PC. Little flashback there if you have an interest in such things.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week's a Dan Maloney twofer. I'm going to start off with his Ask Hackaday, what would you do with the world's smallest microcontroller? And this was coming on the heels of a TI press release and video where they're showing off this incredibly tiny little microcontroller that uses just the smallest set of 8 ball grids you've ever seen in your life. The chip is the size of an 0603 resistor, basically. Gosh. It's 1.6 millimeters by 0.8 millimeters wide. It's under a millimeter wide. I don't know how you do the routing for this thing, but I guess it's only 2 rows and it's only 8 pins. So, it's probably not that bad. Maybe it'll work. It's a small microcontroller. It doesn't have all that much memory. It's got, power and ground eating up 2 of the pins. So it's got 6 free GPIOs. So that kind of limits what you can do with it. But, the question, and this is why this is an Ask Hackaday, what would you do with this thing? I think the first comparison is kind of, in my mind, the microcontroller itself has about the power of an old AT Tiny and about the same number of GPIOs. So kind of any of the tricks you could do with an AT Tiny 85 back in the day, you could probably do with this thing. And the
It's a
fact
Cortex M0, isn't it?
yeah, it's a Cortex M0, so it runs a little faster. It's got a little more memory, but the basic functionality is kind of broadly similar, updated for the times. They're looking at a price of 20 cents each in quantity 1000.
Not bad.
So it's actually not bad. I couldn't find them for sale yet. Take this all with a grain of salt, but they're due to be shipped fairly soon.
Don't lose it among your grains of salt.
Yeah, right? And so that's what I think is the best about this is it's an Ask Hackaday, right? So it's an invitation to leave your smart ass comments in the comment section. And our commenters do not disappoint. I think the most common answer to what would you do with it by far is the obvious one, which is lose it somewhere when you're trying to manufacture it. Sneeze and they're gone. But then the practical answers end up being, just kind of what you'd think, all sorts of distributed computing ideas. With these being as small and as cheap as they are, you could put them right up next to any sensor that you wanted to read information from, for instance, and then take care of all of the analog stuff really close to the sensor where you don't have to worry about interference and just transmit the result digitally to wherever else. They have a really, like all modern microcontrollers, they've got a pretty low standby current. So you could totally use this in, embedded wearables. Somebody suggests a ring. Of course you could. My God, they're using bigger chips in rings these days. You could just kind of scatter them all around your project. But that then brings to the table the one thing I've always wondered about this. Remember the smart dust idea where like everything would have a little microcontroller in it? And I've always loved that idea, but after having just flashed 300 badges, it makes me think who's going to update the firmware on the smart dust and how? And like you'd spend more copper on the in-circuit programming lines than you would save in having so many distributed microcontrollers. I'm just not sure I buy it yet. But if you did need your smart dust, this is basically it. You're basically looking at it. And if Mike Roller wants to shrink down his smallest blinky, this is the way to go.
I think the key here is that it brings a better array of microcontroller peripherals, further down the price and down the size tree. For instance, I've had various friends who, over the last few years, have done experiments with the 3-cent microcontrollers, the Padorks, which were their go-to super tiny microcontroller simply because they're so ridiculously cheap. They're actually a really nasty little copy of an ancient PIC. And the more processors like this come down the tree and start being viable alternatives to difficult options like the Padork, the more useful things can be done in very small things. So it's not so much the fact that it's tiny, it's the fact that it's a more powerful machine in a tiny package, I think.
That's a great take, and I'm totally with you. The M0 in there is just so much more friendly to program than any of the other super cheapies. And this one is actually currently shipping in reasonably sized packages as well right now for actually the same 20-cent price tag. So, I'm not paid by TI to say this, but the other ones would be a great replacement. Get that same thing in TSSOP and you can have something that you can handle without losing it. And it's a cheap as hell microcontroller. So, probably worth digging around. This is one of those things every 2 years, 3 years, it's probably worth it to reevaluate what's out there and go
Definitely.
microcontroller digging, right? And see what the new hotness is. And I haven't done that in 5 or 6. I'm probably 2 cycles too stagnant. Oh, that's not true. I've been using the WH32 V003s. In fact, we put one on a SAO for the badge this year, and I learned to write a programmer for it and had a good time with that. They're fun to use, a little bit awkward, not quite as comfy as the ARM chips, but so much cheaper, and they actually have a really capable ADC on them. So trade-offs here and there. It's worth your while. Dig around, try out a whole bunch of new microcontrollers when you get them. And yeah, maybe this one's the next one to try.
We'll definitely look forward to see what people come up with this particular tiny chip. Go forth and make stuff, people.
I like one of my other favorite ideas is, since it's smaller than a bunch of resistors, you actually hollow out like a 1206 surface mount resistor. You can hide it in there. There's flashback to that old spy chips conspiracy, and you can put a 555 timer in your circuit, make it look like the 555 is doing the blinking, but actually have this little microcontroller do it, buried under another surface mount resistor.
Just hollow out a 555.
Oh, well, that's too big. 555, you could.
This is a resource extraction story. It's a common thing. Every few months, there's a scare story that something, usually lithium or rare earth elements, is running out, and the Chinese will end up with it all if we don't do something. And invariably, it's whipped up by sort of ignorant newspapers, and soon afterwards comes another story that a source of rare earth elements has been found in something relatively straightforward. For instance, an example, a couple of years ago, they discovered that the water from some British geothermal wells was full of rare earth elements. And this is one of those stories that, despite rare earth elements being terribly, terribly rare, it turns out we have vast amounts of them in the form of coal fly ash, because we've spent sort of 100 years or more burning vast amounts of coal, and particularly in power stations, you produce enormous quantities of the stuff, and it usually goes into your nearest landfill. And it turns out that what we've done is concentrate all the stuff that wasn't coal into the ash, which includes all the rare earth elements. And if I had a quid for every time I've heard this story that rare earths are going to run out, I would probably be very rich by now. I wouldn't be writing for Hackaday. Of course, it's not all good, because there have been numerous stories over the year pointing out that, as well as concentrating down the likes of rare earth elements, you also concentrate any radioactive elements in the coal. So, for instance, uranium, thorium, stuff like that. And there is convincing research to suggest that a coal-fired power station over its lifetime boots out far more radioactivity on its neighbouring landscape than a nuclear power station would. And having grown up not too far away from a very large coal-fired power station in South Oxfordshire, I look upon that and wonder how many isotopes in my bones there are that wouldn't be there if it had been a nuclear power station. But then again, just up the road is Aldermaston, Culham and Harwell nuclear research stations, so probably I've been irradiated from all sides. But this is an interesting story because pretty much everywhere in sort of Europe and the US, we've got vast amounts of coal ash, and there's gold in them there hills of dirt.
They're not rare in that there isn't much of it in the earth. It's just that you have to spend a lot of effort to concentrate it, to get it out of whatever, it's in the presence of so much other stuff. It's rare in that sense. It's low density in the Earth's crust. But a lot of these are also everywhere in the Earth's crust. And so that's kind of what's interesting here, is that by accident, you've already done kind of refining here. Right? Like by accident, you've burned off the coal, which is most of the mass, and then what you're left with is this concentrated pile of stuff. And it's funny because I was out visiting my folks in Colorado, and we were out at a gold and silver mine, and they frequently in that industry go through the tailings again. So what happens is they do their mining, they extract all the silver they can, and then they just throw the stuff that they don't profitably extract silver from in a big pile. Well, later on, when the silver price increases, that pile turns out to have enough silver in it that it's now economically viable to go through it once again and extract the silver again using better and maybe more expensive chemical technique than they had available in the 70s. because they've already kind of done the first stage of pulling it up out of the earth, it's cheap and easy to just re-refine it and get the silver out when the price is right. And I wonder if that's part of the same thing here, is that, we've been burning coal since God only knows how long. But, back then, the rare earth elements weren't worth as much. Like, nobody wanted scandium back in the 50s. But now maybe you do. Now maybe you have a reason to fetch it on out. So it's, makes sense to pull it out of the old ash piles.
I'm reminded reading somewhere that there was a thriving industry in the north of England in the 18th century extracting lead from the tailing piles of Roman lead mines, because the Romans were not very good at getting lead out of it.
Right? Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. The tips line is tips@hackaday.com, and all our links, you'll find them at hackaday.com/podcast. And until next week,
Eat, sleep, hack, repeat. Chris Doble, innit?
just to get charged.
Oh, blimey.
If you have any tips for us, the tips line is at tips.hackaday.
I think that's it.
Then that's a wrap.